Okay, in this video clip we're going to work our way through the Edexcel non-calculator June 2014 higher tier exam paper with the code 1M80-1H. Now the first page you come to is the formula sheet. Now this sheet is really important to remember it's there as you're working your way through the whole of the exam paper, as you never know if there's going to be a formula that you could use to gain a few extra marks on a question anywhere in the exam paper. And you can see at the bottom here, I've added a couple of points that I'm walking into that exam trying to remember. Now I know it says you must not write on this formula page. The reason they've put that is because anything you do put on here just won't gain any marks. Now I'm not after any marks for this, I'm just trying to find somewhere to write these down so I've got them stored ready if I need them throughout the exam paper. And I've got cherry pie delicious, apple pies R2, which is the way I remember the formulas for circumference and area of the circle, and I've got my some old horses can always hear their owners approach, the SOHCAHTOA for any trigonometry questions. Right, let's have a look at question number 1. Right, we've got two parts for question number 1, part A and part B, 1 and 2 marks with a total of 3 marks for question 1. Work out 1/7 times 2/3. When it comes to times in fractions, you simply times across the top, times across the bottom. So 1 times 2 is 2, 7 times 3 is 21. Double check this answer to make sure it can't be simplified down. Now, if I was to take that to a 1, I'd have to half this number as well, and that's an odd number, so it can only be halved to a decimal. So that there is already my simplest fraction for part A. So 2/21 for 1 mark. Part B, work out 3/5, take away 1/3. Now when we add and take away fractions, we've got to have the same denominator. So the number on the bottom here has got to be the same first. So I've got to get the 5 to a number that the 3 can also get to. Now there is a way of finding that out. You can just times the two denominators together. So 5 times 3 is 15. So both 5 and 3 will fit into 15. Whatever I do to the bottom to get to 15, I must also do to the top. So what I'm going to do to this 5 to get it to 15 is times by 3. So I've got to do the same to the top. What I'm going to do to this 3 to get to 15 is times by 5, and I'm going to do the same to the top. So I'm going to get two brand new equivalent fractions. 3 times 3 is 9 on top of 15. Take away 1 times 5 is 5 on top of 15. When you've got the same denominator, when the number at the bottom is the same, we're allowed to then do what it says here, take away the top numbers. So 9 take away 5 is 4. The denominator yet again stays the same. So my answer is 4/15. Again, let's check this and make sure it's in its simplest form. Okay, if I was to half this down to 2, would this be able to be halved? No, again, it would go down to a decimal number. Is there any number that fits into 4 and 15? There isn't. So this is the simplest form for the 2 marks. So 4/15 for part B, with a total of 3 marks for A and B. Times across. Take away, get the denominators the same first. Part A, part B, 1, 2, 3 marks in total. Let's move on to question number 2. Question number 2 is worth 3 marks, and you can find support on this type of question with the top 40, clip number 3. Here are the times in minutes that 20 children took to walk to school. Then we've got this list of numbers. Draw an ordered stem and leaf diagram for these times. Blank space, a stem and leaf grid, and be careful, sometimes they don't print this for us. This is a little bit of a hint on this exam paper. Likewise with the key box. We're expected to put a key, but sometimes they don't put this key box, but we are expected still to put a key. So we've got a couple of hints here on what they look like. This space here is where I'm going to draw a stem and leaf diagram straight from the list, so out of order. The ordered stem and leaf is what I'm going to put on this printed one here. So first of all, in this space, I'm going to create my own first stem and leaf box. Now with the stem and leaf, on this side, the stem, we put the tens number. So the number at the front in this case. in the leaf part here, we're going to put the unit number that goes with these tens numbers. So let's look at what we've got. I've got numbers less than 10. So anything that's less than 10 doesn't have a tens number, so that's going to be a 0 for the less than 10 part. Anything in the tens, for example, this 13 has a 1 for the 10 part. The 20s numbers, there's 30s numbers as well, and I think it even goes up to 40s. So I've got numbers less than 10 in the 10s, in the 20s, in the 30s, and in the 40s. And then I'm going to go through the list and apply and add in the unit number into the list. I'm just going to do it in the order that's here. So 13, I'm going to tick it off so I know I've used it. It's going to put a 3 in the 10 column. 21, 19, and ticking them off as I've used them so I know I've not missed any out here. 27, 31, which is going to go a 1 in the 30s column. The 5 is going to go in the less than 10 column there. 23, 29, 18, 25, 34, 15, 28, 23, 22, 40, that means I'm just going to put a 0 for the 40, 4 with a 0, 40, 16, 19, 32, and finally 9. I'm just going to do a quick check at this point. It said 20. There should be 20 leaf numbers in here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Now when it comes down to this part here, this has got to go in order. So it's going to be the same, exactly the same as what we see here, but with the leaf numbers in order. So I'm going to have 0, 10s, 20s, 30s, and 40s, and then these numbers in order. So this one is already in order, 5 to 9, so 5 going up to 9 there, 5 and a 9. Then these ones here is going to be a 3, 5, 6, 8, and 2 9s. So I've got 3, 5, 6, 8, and then 2 9s in order, smallest to biggest. This one's going to start with a 1. And again, you can tick them off in here as you apply them down into the ordered one. 2, 3. There's another 3. Then we're going to move on to a 5, a 7, an 8, and a 9. 5, 7, 8, and a 9. This one is quite easy. It's a 1, 2, and a 4, and the final one is a 0. Now, what I do advise at this point again is do a quick count and make sure that we've again got 20 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So there's my ordered stem and leaf diagram. And in my key, you can choose any number you want for this. I always tend to go for the first number here. So 0, line 5. What that actually equals is a 5. I could do here 4, line 0 equals 40. 3, line 1 equals 31. It doesn't matter, but I always tend to use the first one there. So we've got our out of ordered stem and leaf, which is from the list of numbers up here. Then we've got our in ordered version of the stem and leaf, just changing the leaf part, this part here, in order, so smallest up to biggest. And then for the key, I've just chose my first one and actually explain what it means. 0, line 5 actually equals 5 for the 3 marks. And again, you can find support on stem and leaf questions and all the extra bits that go with stem and leaf questions actually on the top 40, clip number 3. Right, let's move on to question number 3. Right, question number 3 is worth 4 marks, and you can find support on this type of question with the top 40, clip number 1. 50 people each did one activity at a sports centre. Some of the people went swimming, some of the people played squash, the rest of the people used the gym. 21 of the people were female, 6 of the 8 people who played squash were male, 18 of the people used the gym, 9 males went swimming. Work out the number of females who used the gym. We've got quite a lot of words. And again, top 40, clip number 1, this is a two-way table question. And what gives it away is that we're talking about a total number of people that could choose different options, male and female split. So my two-way table is going to be male and female down the side with total. And then if I put some lines here going across, I'm going to have my options going across the top here. And the options were swimming, squash, gym, and again, that key word that actually makes this a two-way table, total. Because I've got a total working across and I've got a total working down. Now the first key number is actually the very first number that's here, 50. 50 people each did one activity. So 50 is the total in the bottom right hand corner of my two-way table. Then I'm going to work my way through these sentences here. 21 of the people were female. So female total is going to be 21. Now I can automatically work out this box here. I can know how many males there are, because if there's 50 people in total, I've been told there's 21 females, I know that there's got to be 29 males for it to add up to the 50 there. So I've dealt with this first sentence here. 6 of the 8 people who played squash were male. So that means 8 people played squash. There was a total of 8 people who played squash, of which 6 were male. So squash, there must have been 8 people in total that played squash, and there were 6 that were male. So that must mean there was 2 female. 18 of the people used the gym. So gym, it doesn't say if they're male or female, but 18 of them used the gym, so that must be the total. 9 males went swimming, so that's this cell here where these meet, so 9 males went swimming. Now that's dealt with all of the numbers I've got up in the words in the question there. So I should have enough information here now to be able to finish off the two-way table. So let's see what we've got and what we can get to. Now, across the bottom here, if you can see, 8 and 18 plus whatever this number here is gets to 50 as you add up going across. So my 18 plus my 8 comes to 26. So that must mean there's 24 left over for it to all add up to get to 50. Once I put that 24 in, 9 plus something comes to 24, and that's 15. Now 15 plus 2 is 17, plus something else gets me up to 21. So 17 up to 21 is 4. And then 4 plus 14 is to give me the 18. Now I always advise spending a bit of time double checking that all your rows add up to the numbers you've got here in this total, and all these columns going down, again, add up to the total at the bottom. Going across adds up, going down also adds up. Work out the number of females who use the gym. So females who use the gym is here. So the actual answer to this question on the dotted line down the bottom is 4. So again, we've got a lot of words, but what gives it away is that we've got these topics, these subjects, these options that are happening here for the male and the female people who go to this sports centre. So male and female going down the side, and then the options that they can have going across the top with the keyword total. We've plugged in the numbers that we see all the way through the question into the right cells, and then we finished it off, and the actual question was work out the number of females who use the gym, which is 4 for the full 4 marks for question number 3. And again, support for two-way tables, top 40, clip number 1. Let's move on to question number 4. Question 4 is worth 4 marks. Mr. Brown and his 2 children are going to London by train. An adult ticket costs £24, a child ticket costs £12. Mr. Brown has a family rail card. We get a third off adult tickets and 60% off child tickets. Work out the total cost of the tickets when Mr. Brown uses his family rail card. So we've got one adult and two children. So we're going to have one of the 24 and two of the 12s. But we do get this discount here. So let's work out what the adult and the child ticket costs when we apply these discounts. So a third off adult tickets. So we're going to get a third of £24. That's what we've got to work out first, a third of £24. Now a third means to divide by 3 and you want one of them. So if you do 24 divided by 3, that's 8. 24 divided by 3 is 8 and you want 1 8. So a third is £8. So an adult ticket is going to be 24, take away the £8 discount, which comes to £16. So it's going to be £16 for an adult ticket for Mr. Brown when he uses his rail card. A child ticket costs £12 and you actually get 60% off the child tickets. So let's work out what 60% of 12 is. So 10% is our key percentage we're going to work out first. Now there's no 0 on the end. The decimal point isn't visible, but it would be there. And to find 10%, we hop the decimal point in 1. So it's £1.20 for 10%. Now 60% is 6 of these. So I need 6 lots of £1.20. Now I can line them up and add them up. Or I could do 6 lots of the £1, which is £6. 6 lots of the 20p is £1.20. So that's going to be £7.20. £7.20. So 10%, £1.20. 60% is 6 lots of the 10%, so £7.20. I just did 6 lots of the £1 is £6. 6 lots of the 20p is £1.20. So 6 plus £1.20 is £7.20. So the child ticket costs 12, take away the £7.20. Put the pounds on there as well. So 12 take away £7.20 is going to be £4.80. So again, £12 take away, that's 60%, leaves me with £4.80. So the total day out it's going to cost Mr. Brown is going to be £16 for his ticket. And he's got 2 children, so I'm just going to line these up as if it was £16 and no pence, £4.80 for the one, and then £4.80 for the second child. 8 plus 8 is 16, carry the 1, decimal point here. 10, 15, carry the 1 plus the 1 is £25.60. It's going to cost Mr. Brown to take himself and his 2 children. And all we did was work our way through the discounts and then apply the discount. So a third of 24, divide by 3, £8, we took away the £8. 60%, we worked out 10% first, £1.20. 60% is 6 lots of that, took it away, £4.80. 1 adult, 2 children. 1 adult, 2 children, added them up, £25.60 for question 4 for those 4 marks. Let's move on to question number 5. Okay, question number 5 is worth 2 marks, and you can find support on the top 40, clip number 6 for questions like question number 5. Rebecca wants to find out how many books people buy. She's going to use a questionnaire. Design a suitable question for Rebecca to use in her questionnaire. Now, for the 2 marks, we need a question, but we also need response boxes. So we need to ask how many books people buy, but within that question, we need to have a time span, a time frame. So per week, per month, per year. So how many books do you buy is going to be my question. How many books do you buy per, and I'm going to say per month. It doesn't matter what time span you use, as long as you do have a time span there. And then we need to have an option for 0, and I like to have 0 on its own, but it doesn't matter if you start spanning from 0 up to, say, 2 or 3. My next box is then going to be 1 to 5, say, but at this point, let's just make sure we're not doing any overlapping. 0 to 1. We haven't got 1 or 0 in 2 option boxes. So again, here, I can't put 5 up to something else. I'm going to do 6 to 10. And then my final box, and I like to use 4 boxes. You must use a minimum of 3, but I like to have 4, is going to be 11, which is the next number with a plus sign on it to show 11 or more. Whereas 0, 1 to 5, 6 to 10, and then 11 or above. I've got my time span, and I've asked my question with my response boxes for the 2 marks for question number 5. And again, top 40, clip number 6 for support on that type of question. Now on the same page is question number 6. Question 6 is split up into 2 parts, A and B. 1 mark for part A, 2 for part B. And you can find support for part A with the top 40 clip 39. So support for part A with the top 40 clip 39. Expand, and I've got some brackets. That means whatever's on the outside of the bracket has got to multiply whatever's on the inside of the bracket. So that 2m is going to multiply the m and also the 3. So 2m times m makes 2m squared. Plus sign stays the same. The 2m times the 3, it's going to be 2 times 3, so it's going to be 6. Don't forget the m that's there on the outside still with the 2m. So my answer is 2m squared plus 6m for the 1 mark for part A. Whatever's on the outside of the bracket multiplies whatever's on the inside. Part A, support, top 40, clip number 39. Now part B, factorise, is the opposite. It's actually going to be putting brackets back into this, what we see here. So I've got to look at the numbers first. There's a 3 and a 6. What fits into, what factor, what's the biggest factor of 3 and 6? Well, 3 fits into both. So I'm going to have a 3 on the outside. Let's look at my letters. I've got X's on both sides, an X and an X. So there's an X on both sides. Now I've got a y squared and a y on both sides. So the one that fits into the factor of y squared and y, what fits into both is going to be a y. Now I've dealt with everything that's here. I can open my bracket. 3 times a number is going to give me 3. So that's 3 times 1. Now I can put the 1 there if I want to, but there will be letters involved. So I don't have to put the whole number 1 there. So to get from the x to the x inside here, I've already got the x on the outside, so I don't need another x on the inside because I've already got it outside. But I've got a y and I need a y squared, so I'm going to need a y. So 3xy times y is going to make 3xy squared. I can put the 1 there in front of the y if I want to, but I don't need to. The takeaway sign. I need to get 3 to 6 this time, so I'm going to multiply it by 2. I've got an x, I need an x. I've got a y, I need a y. I don't need any squared versions of them, so the x and the y are already taken care of outside the brackets here. Close your bracket, we're finished for the 2 marks for part B. So part A, support with the top 40 clip 39 with expanding, and then we've got factorising, which is the opposite. It's actually putting brackets in for part B for the 2 marks there for question 6. Let's move on to question number 7. Okay, question number 7 has got this asterisk here, this little star, which means we are going to get marked on our quality of written communication. It means that we're going to get a mark for our sentence at the end just to finish off this answer. Question number 7 is worth 4 marks, and you can find support on this type of question with the functional skills videos for area. The diagram shows the plan, which is the view from above of a small field. So this is the small field from above. Diagram not accurately drawn, the standard phrase there next to that picture. Kevin is going to keep some pigs in the field. Each pig needs an area of 36 square metres. Work out the greatest number of pigs Kevin can keep in the field. So what really we're asked to do is work out the area of this field and then chop it up into 36s, because that's how much each pig needs. See how many 36s fit into what I've worked out this area of this field to be. Now, this is a compound shape, so it's not a straightforward shape, so I'm going to have to chop it into two easier shapes. Now, you can either chop it going across there to make two rectangles, and I'm going to actually chop it going down here to make two rectangles. Now, because I have chopped it there, I'm going to have to adjust the number in here. So 16 goes all the way across, but I want to know what this part is. Now, if we look down here, that's 7 meters. So let's bring up that 7 as well, because that will be 7. So 16, take away the 7. This part here is going to be 9 meters. So now I've got two rectangles where I can actually work out the area of the rectangles. This one is 9 times 6, 54 meters squared. 9 times 6, the length times the width here. Now this one is going to be 10 times 7, so this one is going to be 70 meters squared. So I've just, by chopping it up and looking at the numbers around, making sure I'm multiplying the right numbers to get the area for the correct rectangle. So I've got 70 meters squared there and 54 meters squared there. So the area of the whole field is 70 plus 54, which is 124 meters squared. So the area of this entire field is 124 meters squared. Now, each pig requires an area of 36 meters squared. Now, all I'm going to do, I'm just going to add up, because it's a non-calculator paper, I'm just going to add up in 36s until I reach my 124. So 36, if I add another 36 on, that comes to 72. So that's 2 pigs so far. If I add another 36 on, that comes to 108. So that's 1, 2, 3 pigs so far. If I add another 36 on, that comes to 144 meters squared. Now, I've gone over my 124 here. I've gone over 124 meters squared. Don't forget, each pig requires an area of 36 squared meters, which is 36 meters squared. And I've just added up in 36s to see what happens when I get close to the 124. So 36 plus 36 came to 72. So that was 2 pigs. I added another 36 on. 3 pigs gets me to 108. But I can't add a 4th pig on because it takes me over the 124 meters squared. It takes me to 144 meters squared. So I'm not allowed that last 4th pig there. So 3 pigs is the greatest number that I can keep, or Kevin can keep, in this field here. So I'm just going to finish off with that sentence. Kevin can keep 3 pigs. And there's my quality of written communication, my final sentence to finish off to show what I've worked out here in words for my final answer. So I chopped it up, made it 2 nice easy shapes, worked out the area of both, added those together, and just simply added up in 36s to see how many I could fit into the 124 there. And again, it's a non-calculator paper, so I can't just do 124 divided by 36 on a calculator. I've done a little bit of an adding up method to see how many fit into the 124. And Kevin can keep 3 pigs. 4 marks for question 7, and again, support on the functional skills video for area for question number 7. Let's move on to question number 8. Question number 8 is worth 3 marks. The diagram shows a garden in the shape of a rectangle. The scale of the diagram is 1 centimetre represents 2 metres. Then we've got the diagram here of the garden with the patio and the circular pond. And again it says scale 1 centimetre represents 2 metres. So that means 1 centimetre on this picture would be 2 metres in the real garden. Irfan is going to plant a tree in the garden. The tree must be, then we've got these 2 points here, more than 3 metres from the patio and more than 6 metres from the centre of the pond. On the diagram, show the region where Irfan can plant the tree. So again, we've got this diagram here where 1 centimetre is representing 2 metres. We've got these 2 rules here that we've got to abide by in order to find the region where Irfan can plant the tree. Now the tree must be more than 3 metres from the patio. So it must be more than 3 metres that way and more than 6 metres from the centre of the pond. So the centre of pond here, so more than 6 metres away from that pond. And then we've got to find that area where we're allowed to plant the tree. But the rules here are in metres. And don't forget the image is in centimetres representing this real garden, which would be in metres. So what we need to do is look at these 2 points that we're being asked to work with and change these into centimetres. Look at the scale. 1 centimetre represents 2 metres. So 1 goes to 2. If it was 2 centimetres on the picture, that would mean it would be 4 metres. So the centimetres is half the value of the metres. So what I can do, I can change these 2 numbers here to be in centimetres. So 3 metres on the real garden, on the image, would actually be 1.5 centimetres, half of this amount. So the 6 metres on this picture here would be 3 centimetres. So now I know what I've actually got to apply in terms of this picture, 1.5 centimetres and 3 centimetres for these 2 rules. So the first one, we've got to be more than 1.5 centimetres from the patio. So I've got to be more than 1.5 centimetres away from that patio line there. So what I need to do is just get a nice straight line that's 1.5 centimetres. So I'm going to put 1.5 dash at the top, 1.5 centimetres dash at the bottom, and then with a ruler and a nice sharp pencil in the exam, we're going to join those up. So I can be this side of the line to plant this tree. I cannot be this side. So that's the first point. The second point, we've got to be more than 3 centimetres from the centre of the pond. Now the pond's circular, so that means 3 centimetres away from the centre there is going to be in a circular shape as well, because I've got to be 3 centimetres away from it in all points. So that's where I need to use a compass. Now I'm going to put my pencil inside this compass, and I'm going to open this compass up at 3 centimetres. So let's bring the ruler in, open this up at 3 centimetres, so the spike and the pencil are going to be laid out on the ruler, there we go, at 3 centimetres distance between the 2. And then the spike of the compass can go on the centre of the pond. And we're going to draw an arc going around the pond. Now I'm stopping as it hits the edge of the garden because I don't need to carry on past the garden. So that there is showing 6 metres, so 3 centimetres away from the pond in all directions. This one was 1.5 centimetres, so 3 metres away from the patio. So it's got to be this side of the line and this side of the curve. So if I just put a quick shade in this area to show this is where I'm allowed to plant the tree. On the diagram, shade the region where earthen can plant the tree, this side of the curve and this side of the line. The shaded part is where we can plant the tree. Right, let's move on to question number 9. Now question 9 is split up into 2 parts. Part A worth 2 marks, and you can find support on part A type questions with the top 40 clip number 22. And then on the next page we've got part B, again worth 2 marks, and you can find support on this type of question, part B, with the top 40 clip number 20. So we've got 2 parts A and B with 2 separate support clips, clip 22 for this part A and clip number 20 for part B. We've got our axis drawn for us here. We've got this shape A, and it says on the grid rotate shape A 180 degrees about the point 1, 1 for 2 marks. Now, about the point 1, 1, I'm going to find that point 1, 1, which is along the corridor and up the stairs 1, 1, and I'm going to put a cross. That's my centre of rotation, about the point, my centre of rotation. I'm going to rotate this shape 180 degrees, which is going to be 2 turns of tracing paper, It doesn't matter if I go left or right. It doesn't matter if I go anti-clockwise or clockwise, because whatever direction you go when you do 2 turns, you're going to get to the same position. So the first thing I'm going to do is lie my tracing paper over the page there and completely cover this diagram. I'm going to make sure I line up the top of my tracing paper with the top of the exam paper. I'm going to get it lined up on the side with the side of my exam paper so it's nice and straight. And again, top 40 clip 22 goes into explaining this. And I'm going to draw shape A onto the tracing paper. I'm also going to put the cross there for that centre of rotation, about the point. I'm going to pincer my tracing paper at that point. I'm going to hold it down with my pencil here. And I'm going to pull this across a bit so you can see as it rotates. I'm going to do 1 turn. So that means this top edge is then going to be on this side. If I go to the right clockwise, that's lined up nice and straight with the right hand side. And then I'm going to do another turn. So it's now at the bottom of the page, as you can see there. And that is where shape A gets rotated to. So I'm just going to pincer through a little bit so I can see the dots as I take the tracing paper away. So redrawing that in. That is the new rotated shape. When A is rotated 180 degrees, it doesn't matter about going clockwise or anti-clockwise, because 2 turns. It would do if it was 90 degrees or 270. I'd have to make sure I'm going the right way. And I've pincered my tracing paper at the right point, which was here. So this is rotated round to here. For part A, for 2 marks, and I got 40, clip number 22 for question 9, part A. Moving on to part B. This is top 40, clip number 20. So it's again one of those transformations. So we've just seen the rotation as one of those transformations. We've got another one of the transformations here for part B. On the grid, enlarge triangle B by scale factor 3. That means to triple it up, centre 0, 0. First of all, like I did in the previous part, part A, I'm going to put a cross here where that centre is, which is 0, 0. Scale factor 3 means I'm going to triple up this shape. Now I can't just triple it up anywhere I want to, because I've got this centre. I've got to do it in a certain position. So what I'm going to do, I'm going to count from here to this corner first, which is 1, 2, 3 to the right, and up 1. Now what I'm going to do, I'm going to apply these hops here, a scale factor of 3. I'm going to triple these numbers up. So instead of going to the right 3, I'm going to go to the right 9. Instead of going up 1, I'm going to go up 3. So I've just tripled those 2 numbers. Back to the centre, across 9 and up 3. So back to the centre, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then up 3. 1, 2, 3. That point there is going to be the new point for the triangle here. Now from here on in, that's 2 lines or 2 squares that you can see there, 2 squares. So if I triple up 2 squares, that becomes 6 squares. So I'm going to go up 6 squares from here. So 1, 2, 3, 4, 5, 6. That line going out is 1, so going out in that direction 1, but instead of 1 it's going to be 3, because I've tripled up that number as well. And then I can finally easily just finish this off for the tripled up shape, the scale factor of 3 shape in the right position. And the way I'm going to check it's in the right position is if I join up the 2 points and carry it on, it should come back to the centre of enlargement, which it does. I can check on all of the points and go through the top left-hand corner of the triangle, and again you can see that it actually comes down to the centre of enlargement. So I know I've got that enlarged shape now in the correct place. Scale factor 3 means to triple it up, so I've tripled up that journey to get from the centre of enlargement, which I put a cross on. I've wrote it here and I've tripled up that journey, and then I've drawn in the shape, triple the size, so 3 times the size, and I've done a check to make sure the guideline comes back to the centre of enlargement. 2 marks for part B. 4 marks in total for question 9. Clip number 22 for support with part A, and for this question here, part B, clip number 20 with the top 40 for support on those type questions. Moving on to question number 10. Okay, question number 10 has got this asterisk, this little star again, so we are going to get marked on our quality of written communication, so we must finish off with a sentence for this question number 10. Question number 10 is worth 3 marks. Milk is sold in 2 sizes of bottle. We've got a 4 pints bottle here for £1.18 and a 6 pints bottle here for £1.74. A 4 pint bottle of milk costs £1.18, a 6 pint bottle of milk costs £1.74. Which bottle of milk is the best value for money? You must show all your work in, and again we've got to finish off with a little sentence. So it's not saying which one's the cheapest, because we can see this one's the cheapest. It wants to know which one's the best value for money. So is it better value to buy the bigger one, or is it better value to buy the smaller one? Now what we need to do to compare with best value is by proving the price for both comparably. And what I mean by that is that, can I show what this would cost if it was 6 pints, or can I show what this would cost if it was 4 pints? Now what I could do here, if I halved this, that would give me 2 pints. And then if I add 2 pints back on, it would tell me what it is for 6 pints. So all I'm going to do is half this amount here, so half the £1.18, add it back on, and that's how much that one would cost for 6 pints, and then I can compare it against this 6 pint one here. So first of all, half of £1.18, so I'm going to show all my working out, so £1.18, so half of that, if I divide it by 2, is 59p, so 0.59 or 59p. Now if I add it back on, so £1.18 plus the 59p, that's going to come to 7, carry the 1, 7, £1.77p. £1.77p if this was 6 pints. By halving it, 59p, adding it back on, £1.77. But for 6 pints here, it's £1.74. So we can see straight away it is best value for money to buy the 6 pint straight away at £1.74. £1.77 for 6 pints by using this one here, compared to £1.74 for the 6 pints. So 6 pints is best value. And there we go, finished for the 3 marks for question 10, with a little sentence at the end for the quality of written communication, that starred part. So all I've done is half this, 59p, added it back on, £1.77 compared to the £1.74, 6 pints is best value for money for question number 10. Let's move on to question number 11. Right, question number 11 is worth 3 marks, and we've got this diagram here, and it says ABCDE is a regular pentagon, BCF and EDF are straight lines. Work out the size of angle CFD. You must show how you got your answer. So angle CFD is the angle at the middle letter, the F, so C to F to D, so it's going to be this angle here. I'm just going to put an X there to show that's what we're trying to find out. And we've got no angle numbers here within the words. We've just got some facts that we've got to work on. That's a regular pentagon, a 5-sided shape, and we've got some straight lines. So this pentagon here, this 5-sided shape, is regular, which means these angles inside are all equal. So I've got 5 equal angles, so we need to know what they add up to then divide by 5 to find out what they are for each one in that pentagon. Now, let's go back to thinking what a triangle is. A triangle is 180 degrees for the 3 angles added up inside a triangle. When you go up one side to a 4-sided shape, a quadrilateral, so a square or a rectangle or a parallelogram, they add up to 360. And what's happened is you've added 180 on. Now when you go up to a 5-sided shape, a pentagon, you add another 180 on, so it becomes 540. Now you can carry this on by just adding 180s on each time, for each time your side goes up by 1. So if we go up to a 6-sided shape, a hexagon, we just add 180 on again. So these add up to 540 degrees for this pentagon, this regular pentagon. So 540 divide by 5. So 540 divide by 5. Now I'm going to do this by this long division method. So 540 divide by 5. 5s into 5 go once. 5s into 4 don't go, so I'm going to carry the 4 onto that 0, but 5s into 40 goes 8 times. So each angle inside here is 108 degrees. So I'm going to put on 108 here in the corners for this regular. That means they're all the same, which they are there, 108 degrees. So those 5 108s will add back up to 540. Now the next fact is that these are straight lines. So if these are straight lines, these must add up to 180 degrees. So if I do 180 take away 108 for my next step, and again I'm showing all my working out, 180 degrees for a straight line, take away 108 degrees, that comes to 72 degrees. So these angles here are both 72 degrees. They're on a straight line. And we just did that by 180 take away the 108, 72, 72. Now this here, this triangle must be an isosceles triangle, because the two angles there, if I turn it around like this, the two angles here at the base, these two here at the bottom of these equal lines are 72 degrees. So we've got an isosceles triangle. So going back to this point here, a triangle adds up to 180 degrees, so it's going to be 180, take away your two lots of 72 is going to give you the value for x. So I'm going to again write that down. We've got 180 degrees for the triangle this time, take away 72, take away another 72, so it's 180, take away the two lots of 72, that comes to 36 degrees for that value there for x, 36 degrees. There was no numbers in the words, there was no numbers on the picture, we just had to use our angle facts that we know about. Pentagon are built up in 180s, 540. Regular, all of them the same, so we're divided by 5, 108. Straight lines add up to 180. 180 take away this 108, gives you 72. They're both 72. You're left with an isosceles triangle, 180 for a triangle. Take away your two lots of 72, gives you 36 degrees left over for the value of this angle here, CFD. 3 marks for question number 11. Let's move on to question number 12. Question number 12 is split up into 2 parts, A and B. We've got 3 marks for each part, 6 in total, and part A has again got this starred element part, so we must finish off with a little sentence for that quality of written communication mark available here. You can change temperatures from degrees Fahrenheit to degrees centigrade by using the formula. We've got the formula there, where F is the temperature in degrees Fahrenheit and C is the temperature in degrees centigrade. The minimum temperature for an elderly person's home should be 20 degrees centigrade. Now, Mrs. Smith is an elderly person and the temperature in Mrs. Smith's home is 77 degrees Fahrenheit. Part A. Decide whether or not the temperature in Mrs. Smith's home is lower than the minimum temperature should be for the 3 marks. And again, we've got to finish off with a little sentence. So we know it's 77 degrees in Fahrenheit. So we know that F is 77. So all I'm going to do to start with, I'm going to put 77 where I see the F. So in centigrade, it's going to be equal to 5 lots of, open my bracket, and where it was F, I'm going to put 77, take away 32, close bracket, divide by 9. Now my job is to work this out. I'm going to tidy up the brackets first, so this is going to be still a 5 and a bracket, but 77 take away 32 is 45, all over 9. Now what that means there, 5 lots of means 5 times 45. Now 5 times 45, I could add up in 45s, put 5 of them and add them up, but 5 times 45 comes to 225 over 9. So 225, and all I've done is 5 times that 45, comes to 225, and 225 over 9, that means divide. So just like on that previous question now, I'm going to do that division method. So I'm going to do 225 divide by 9. 9 doesn't fit into 2, so I'm going to carry the 2 onto that one to make it 22. 9's into 22, 9, 18, 27, so it fits in twice for 18, and that means there's 4 left over. Carry the 4. 9's into 45 goes exactly 5 times. So what I've done, I've plugged in the 77, which converts 77 back into, so 77 Fahrenheit into centigrade, and it comes to 25 degrees centigrade, so 25 degrees C. The minimum temperature in an elderly person's home should be 20 degrees centigrade. And I've just worked out the temperature in her room, in her home, is 25 degrees centigrade. So the answer is no. Her home is not lower than the minimum temperature. And that's our final sentence for this starred element here. But the maths part of it is by putting 77 here where we see the F. That means 77 take away 32, which is 45. The 5 on the outside means times, which came to 225, and the 9 on the bottom means a divide. I've done that method here. 225 divided by 9 comes to exactly 25 degrees centigrade, which is more than the minimum temperature of 20 degrees. So no, a home is not lower than the minimum temperature, for 3 marks, including the sentence there for part A. Part B, make F the subject of the formula, and then we've got the formula here that we've used already, but they want us to make F the subject. Now what it means by the subject, at the moment C is the subject. It's whatever's on its own equal to everything else. So I want F on its own equal to everything else. So I need to eliminate what's around the F. And you eliminate first the furthest thing away, which is the 9, because it's holding everything together with that long divide by 9. So if I times this side by 9, which is the opposite of dividing by, they will cancel. But I've got to do the same this side. So I'm going to do C times 9. Now that looks nicer as 9C. Equals, let's tidy it up, 5 lots of F minus 32. So I've eliminated the 9 from this side by doing the opposite, times in, doing the same that side. Now I need to get rid of this 5 because the 5 is holding all the brackets in place and the 5 is times in the bracket. So if I divide by 5 and do the same that side. So now it looks like this, 9C over 5 equals, now I don't need the brackets anymore because there's nothing holding the brackets in place. So equals F minus 32. Now to get F on its own, I need to get rid of this minus 32. So I need to add 32. And it's gone from that side, but I also need to add 32 this side. So again, let's tidy it up. 9C over 5 plus 32 equals F. And there we go. F is now the subject. It's on its own. Everything else is the other side of the equal sign. F equals 9 lots of the temperature in degrees centigrade, divide it by 5, get an answer, then add 32 to work out what the value is in Fahrenheit. We've made F the subject of the formula. F is on its own. Now I could rewrite this as F equals and this, so the F is on the left-hand side, but it doesn't matter, the F is on its own. F is now the subject for the 3 marks for part B. Part A, 3 marks, part B, 3 marks. We've got 6 marks in total for question number 12. Moving on to question number 13. Question number 13, yet again, has got the starred element, so don't forget to finish off with a sentence to get our quality of written communication mark. And question 13 is worth 4 marks. We've got this box here, competition, a prize every 2014 seconds. In a competition, a prize is won every 2014 seconds. Work out an estimate for the number of prizes won in 24 hours. You must show your working. Now the first thing I'll spot here is that we've got hours and seconds. We've got different units, so I'm going to have to do some changing of units at some point. But we are dealing with estimate. We're after an estimate, not the exact answer. So, first of all, I'm going to convert 24 hours into seconds, so I'm dealing with the same unit. Now, there's 60 minutes in an hour, and then there's 60 seconds in a minute. So, first of all, let's convert this to minutes. So, 24 times by 60 to get to how many minutes are in 24 hours. Now, this one's not too bad. 6 times 24, again, I could add up with 24 6 times, but 6 times 24 is 144. And then I've got 1 0 involved, so I've added a 0. So there's a 1,440 minutes we're dealing with, but we still want to convert this to seconds. So I'm going to have to do 1,440 times by another 60, because there's 60 seconds in a minute. But what I'm starting to notice here, that these are starting to get quite fiddly, and it is only an estimate. Now, to make my life easier here, I'm going to change this. I'm going to make it a nice round 1,500. So I'm going to make this 1,500 times 60. Now that makes my life a little bit easier. So I can just do now 6 times 15, which is 90, and 1, 2, 3 zeros. 1, 2, 3 zeros. So I've got 90,000 seconds. And again, this is an estimate. This is not exact. I've changed this to make my life easier. I've used that word estimate. I've converted to minutes by times it by 60. That's the exact answer. Then I've times by 60 again to get to seconds, but I've made my life easier to get there. So I'm dealing with 90,000 seconds. In a competition, a prize is won every 2,014 seconds. So I need to divide 90,000 by 2,014. But again, that's going to be quite nasty, and we're on a non-calculator exam paper. So I'm going to do 90,000 divided by 2,000, which is a lot easier. I've made 2014 2,000 to keep my numbers all nice. Now, when it comes to divides, and I've got all these zeros, I can equally knock off those zeros. So 90 divided by 2 is 45. So I've estimated that in 24 hours there's going to be about 45 prizes won. So work out an estimate. I've rounded these sums as I've gone through for the number of prizes won in 24 hours. So I'm going to put here about, this is for my starred element, about 45 prizes won in 24 hours. That's a sentence to finish off for the starred element. And again, I've really used this word estimate. I've converted first 24 hours into minutes. It was getting a bit tricky to convert it to seconds, so I've made it a nicer number. And then I've divided it by the 2014, but instead of 2014, I've done 2000 again. It's getting a bit tricky, and I've made a nice easy sum out of that, which is 90 divided by 2, so 45. And there's my final sentence, about 45 prizes won in 24 hours for my 4 marks for question number 13. Moving on to question number 14. Question number 14 is worth 4 marks. Emily is driving in France and she sees this sign here with these distances on. Emily is going to drive to Dijon. She plans to drive an average speed of 50 miles per hour. Work out how long it should take Emily to drive to Dijon. Now, these 3 values here are all in kilometres, but we're talking about speeds here in miles per hour. So we do have to recall the fact, and this is a fact that we have to go into that exam knowing, that 5 miles is 8 kilometres. So 5 miles equals 8 kilometres. That's a fact that we need to recall. So if she's driving at 50 miles per hour, now if that had a 0 on and also put a 0 there, that would mean 50 miles per hour means 80 kilometres per hour. So this here means she's travelling at 80 kilometres per hour. How long would it take Emily to drive to Dijon, which is the one in the middle here? 480 kilometres at 80 kilometres per hour. So it's going to be 480 divided by 80. So how many 80s fit into 480? Now there's a 0 on both sides here, so I can take that off. So 48 divided by 8 is exactly 6. So it's going to take her 6 hours to drive to Dijon. And again, I've had to recall, because I've got kilometres here and miles here, that 5 miles is 8 kilometres. 50 miles per hour must be 80 kilometres per hour. It's 480 kilometres, so 480 divided by the 80, I've just taken the 0 off both there, so it's 48 divided by 8 is exactly 6 hours for the 4 marks for question 14, and that there is the key bit of information to help you with that question number 14. Moving on to question number 15. Question number 15 is split into 3 parts. We've got part A worth 2 marks, part B worth 2, and then part C worth 2. And you can find support on the top 40 clip number 19 for helps with parts A and part B. So part A is complete the table of values for y equals x squared minus 2x minus 1. And then we've got these x values here and some missing y values for 2 marks. Part B then goes on to actually using what we found out in part A to plot the graph of what we see here for the values of minus 2 up to 4, which you can see matches the box here for part A. So we've got to work out these missing gaps by plugging the x value that's above the missing space into the equation. So if you was to put minus 2 here where you see x, so minus 2 squared, take away 2 lots of minus 2, take away 1, it comes to 7. So we've got to put minus 1, 0, 3 and 4 into this equation. I'm going to deal with my negative value last. I'm going to do my 0 first, the easy one. 0 squared is 0. 2 lots of 0 is 0. So far it's 0, take away 0, which is 0. Take away 1 goes down to minus 1. Now don't forget, there's going to be no pattern visible here because we are dealing with a quadratic here. We've got a squared, so we can't just think there's going to be a pattern involved. There's not going to be. Let's put 3 in next. So 3 squared is 9. Take away 2 lots of 3, which is 6, and then take away 1. So 9 take away 6 is 3, take away 1 is 2. Put 4 in. 4 squared is 16. Take away, 2 lots of 4 is 8, and then take away 1. 16 take away 8 is 8, take away another 1 is 7. Now minus 1. Minus 1 squared is 1. Take away 2 lots of minus 1. 2 lots of minus 1 is minus 2. Take away 1. Now 2 minuses make a plus, so 1 plus 2 is 3. Take away the 1 is 2. Now you can, although it's not a pattern within the sequence, you can see that it kind of repeats and goes back up. So that's going to be a reflection of what the shape's going to look like down here. So I've squared the x numbers, I've taken away 2 lots of the x numbers and taken away 1, and I've got my values here. Now what I can do with part B is plot these as coordinates. Minus 2 along the corridor, 7 up the stairs. So minus 2 goes with 7, I'm going to put a cross. Minus 1 with 2, minus 1, 2. 0 with minus 1. 1 with minus 2. 2 with minus 1, so this is where it's starting to come back up again here. So 2 with minus 1. And it's a nice clear axis here as well. We haven't had to find any fiddly numbers in between. It's nice and clear the numbers we're finding. 3 with 2, and then 4 with 7, and there's our curve that you can see here. Now without a ruler, a nice free hand, we're going to join these crosses up, and ideally in the exam use a nice sharp pencil for this part. Then if you do make an error, you can rub it out. There we go, our nice U-shape quadratic graph for the 2 marks for part B based on what we actually worked out up in part A there. Moving on to part C, it says solve x squared minus 2x minus 1 is equal to, now first of all let's look at that bit there, that is what we've been dealing with here. That part is what we've already been dealing with, equals x plus 3. Now that part, this first part here, is that curve there. So what I'm going to add onto my picture is what this might look like. Now there's no squares or cubes or anything, so that's going to be a straight line. X plus 3 is a straight line. So x plus 3, so if x is 0, add 3 on, y is going to be 3. 1 plus 3, so if x is 1 plus 3, y is going to be 4. 2 plus 3 is 5, so you can see there's my straight line. Now I can add a few more points on, but I'm going to just use those 3, join them up and carry the line on. I get it nice and accurate. There we go. So I've added that part on. Now solve is where they meet, where they cross over. And you can see that they meet here at -1. So solving is to work out the x value here. So the x value where they meet is at -1. So I've got -1 as one solution. And the other value is where they meet here at 4 for the x value. So -1, 4 is the x values, because that's what we've got here, just the x's. Where this curve that we've already done in part A and B meets this line x plus 3. And I plotted that x plus 3 line there, and it's where they cross over for the x values which they're in line with, which is -1 and 4 for the 2 marks. And again, for part A and B for this question, you can find support on the top 40, clip number 19, for these curve graphs here for part A and part B. Let's move on to question number 16. Right, question number 16 is worth 6 marks, and you can find support with the top 40, clip number 10, for these type questions. Colin took a sample of 80 football players. He recorded the total distance in kilometres each player ran in the first half of their matches on Saturday. Colin drew this box plot for his results, and we've got this box plot for the first half here. Part A, work out the interquartile range for 2 marks. Now the interquartile range is the upper quartile, take away the lower quartile. If it said work out the range, it would be the biggest, take away the smallest. Interquartile, the upper quartile, take away the lower quartile. Now the scale on this is not very nice, so we've got to be very, very careful. It's going to be whatever this number is, take away whatever this number is. So 5.5 is there, which goes up to 6. So we've got to be very careful on what these 1 notches are going up in each time. So 5.5, 5.55, I think they're going up in 0.05s. So 5.6, so every 2 is going to go 0.1 on. So 5.6, 5.7, 5.8, 5.9 and 6. So every 2 squares, 2 little ones here, goes up by 0.1. So 5.6 here. So it's going to be 5.6, take away this one. Now 4.5, again 4.6, 4.7, 4.8, 4.9 and 5. But it's right in the middle here between 4.8 and 4.9. So that's 4.85 here. So it's take away 4.85. So it's fiddly numbers here, and we're on a non-calculator paper as well. So 5.6 take away 4.85. So 4.85, and you can build up to 5.6. That's going to be 0.75. So we've got 0.6 above 5, and we've got 0.15 below 5. So it's 0.6 plus 0.15, which is 0.75 kilometres. So the upper quartile take away the lower quartile, 0.75. There were 80 players in Colin's sample. Part B, work out the number of players who ran a distance of more than 5.6 kilometres. Now let's find 5.6 again on this box plot here. 5.6 is the upper quartile, and it says ran a distance of more than 5.6, so it wants to know this section here, more than. Now the whole point of a box plot is that it's split it up into quarters. That's a quarter of all the information, that's a quarter, that's a quarter, and that's a quarter. So that there is 25%, or a quarter, of how many people we're talking about, which is 80. So we need to find 25% of 80, or a quarter of 80, depending on how you want to put it down. So I'm going to put a quarter of 80 We half it and half it again to get to a quarter. So a half of 80 is 40, half it again is 20. So there are 20 players who run a distance of more than 5.6 kilometres. That there is a quarter of whatever we're talking about. Colin also recorded the total distance each player ran in the second half of their matches. He drew the box plot for this information, so this is the second half. Part C, compare the distribution of the distances run in the first half with the distribution of the distances run in the second half. So we're comparing these two box plots. And again, support with the top 40 clip number 10. We need to put 2 points that are comparing these, and it's always the same two things they're looking for. The first one is where the median is. Who's got the highest median? Now the highest median is up here in the first half. So my first point, and again it's worth 2 marks here, so I'm just going to put it down as bullet points here. So my first point for my first mark is higher median in the first half. So we've compared the median, that's the first one. Now the second bullet point for the second mark is you have to go in a bit more depth on this part. You've got to compare the interquartile range. So the spread, the size of the box here. Now it's quite tight here if you can see. They're very similar. Now for part A we've worked out the interquartile range. So I'm going to work out the interquartile range here for this second half. So that's going to be 5.1. Take away this one here, so that's going to be 4.1, 4.2, 4.3, 4.35. 5.1 take away 4.35 is also 0.75. We're 0.1 above 5 and we're 0.65 below 5. So the difference between these two numbers, if we take those away, again you can line them up and do a proper subtraction. Now what this means in terms of our second point is that they're actually as consistent as each other. So when you've compared the interquartile range, what we found is they've both got the same interquartile range of 0.75. So I'm going to put here same interquartile range. I'm going to put IQR for interquartile range. It's got the same interquartile range. But we do have to put this part in context to the question. So both halves of the match, so both halves as consistent as each other. So both halves of the match are as consistent as each other because their interquartile range are the same by doing the upper quartile take away the lower quartile. So the first point we pull out is who's got the highest median, which was the first half. The second point is you compare the interquartile ranges, and then if one does have a higher interquartile range than the other, you can compare them that way, but this time they've both got the same interquartile range, so they're both as consistent as each other. Both halves as consistent as each other for the same interquartile range, higher median in the first half for the 2 marks. And again, support on this type of question with the box plots you can find on the top 40, clip number 10. Let's move on to question number 17. Question number 17 is worth 4 marks and we're split up into 3 parts, part A, B and C. Part A, write down the value of 10 to the power of 0. Now anything, any number or any letter to the power of 0 is 1. So x to the power of 0 is 1. Y to the power of 0 is 1. 8 to the power of 0 is 1. Anything to the power of 0 is 1 for 1 mark for part A. Part B, write down the value of 10 to the power of minus 2. Now the minus can be dealt with by rewriting it as a reciprocal. And then the minus goes and it's just 10 squared left on the bottom. So the minus goes when you make it a reciprocal 1 over. And then this is much easier to deal with now. 10 squared is 100. So my answer is 1 over 100 for the 1 mark for part B. The minus goes to a reciprocal, a 1 over, 10 squared on the bottom, 10 squared is 100. Part C, write these numbers in order of size start with the smallest. And then on first inspection of these, it looks like these three are written in standard index form, and this is an ordinary number. But when you look a little bit closer, this one's fine. This is definitely in standard index form because that number is between 1 and 10, but these two are not. So I'm going to have to change these two into standard form, make this one also standard form, then we've got all of them in the same format that we'll be able to compare and actually write them down smallest to largest. So this one's okay, I'm not going to change this one, but this one needs to be addressed. 27.3, it's bigger than the 10, so I've got to hop the decimal point in to make it 2.73. Times by 10. Now I've made this one hop to make it smaller, so I need to balance it out. I need to make that number there one bigger. So minus 3, one bigger, becomes minus 2. This number here, again, is not falling between 1 and 10, so I need to make this smaller. I need to make this one to be 2.73 also, times by 10. Now the decimal point's at the end of this number, because we don't see a decimal point. I've done 2 hops to make it smaller, so I need to balance it out by making that number 2 bigger. So 2 goes up to 4. And the final number here needs to be in standard form. So again, 2.73. The decimal point has gone 1, 2, 3 hops, times by 10. Because it's a 0 point number, it's minus 3. So now I've got 4 standard index form numbers, and I can compare those to put them in order smallest to biggest on the line. So the smallest number is going to be the power of minus 3. The smallest power here is minus 3, so that's this number. Now I'm not going to write this down as my answer on the answer line. It was what was originally there. So 0.00273 is the smallest one. I'm just going to tick that off so I know I've done it. The next smallest is the other minus power, this one here. 2.73 times 10 to the power of minus 2, which came from this one. So 27.3 times 10 to the power of minus 3. The next smallest is going to be this one, which is times 10 to the power of 3, because this one here is now 10 to the power of 4, so that's the biggest. So this is the next smallest, 2.73 times 10 to the power of 3. And the final one is this 273 times 10 squared, which we worked out to be in the biggest when we can put them all in comparable formats of standard index form. So there we go, smallest up to largest, as written down as the same numbers that are in the question, even though I've had to change a couple just to be able to compare for the 2 marks there for part C. So that's question 17 with quite a few marks available overall. Right, moving on to question number 18. Question 18 is worth 3 marks. Solve the simultaneous equations that I've got here. X equals Y equals. So I've got to get the value of X that works and the value of Y that works, and it's the same value of X here as it is here, likewise Y and Y. Now I'm going to solve these by the elimination method. I'm going to get either the X is the same or the Y is the same first. So I'm going to choose, and it doesn't matter which one you choose, I'm going to choose to multiply this top row by 3 to make that 3Y. Then they're the same. You could choose to times the bottom row by 4 to get the X is the same, but I'm going to choose to times this top row by 3. So everything's got to be multiplied by 3. So that's 12x plus 3y equals 75. Everything's been multiplied by 3. The second equation is not going to change. Now I've got 3 in front of both of the y's. Now, if I add these 2 equations, it's going to give me a different value of y if I take away these 2 equations. So let's just be very careful on this. 3 take away minus 3. If I take away these 2 equations, 2 minuses end up making a plus. So that'll give me 6y, which is not what I want. But if I choose to add these 2 parts, so 3 add a minus 3, a plus and a minus make a minus, and that becomes 0, which is exactly what we want. It wants it to be eliminated. So I've got to add these 2 equations. 12x add 1x is 13x. These have been eliminated because I've added them together. 3 add a minus 3 becomes 0y. That's gone. Equals 75 add 16, which is 91. To work out the value of x, I need to get rid of this 13. So I need to divide by 13 because it's timesed at the moment. Do the opposite to get rid of it, but I've got to do the same the other side of the equal sign. X equals 91 divided by 13. Now that becomes exactly 7. Now if you wanted to, you could just add up in 13s until you get to 91. Or 91 divided by 13 straight away comes 7. Now I am expecting a nice easy answer and a nice round answer on this question because we are dealing with a non-calculator exam paper. And also I've got to substitute this number back in to find the value of y. So it's got to come out as a relatively easy number. So 91 divided by 13 is 7. If you're struggling with that divide there, just add up in 13s until you get to 91 and you'll find it's 7 times. So x equals 7. I'm going to put that in this dotted line down the bottom. X equals 7. Now I'm going to substitute this value of 7 back into one of these two equations. Now I'm going to choose the top one because there's no minuses involved there. It looks a bit easier to put it back into because I've got this minus on the second one. So 4 lots of x, so 4 times 7 is the first part, which is 28. Add y equals 25. So 28 add something is 25. Now I can see straight away that y's got to be minus 3 to make that work. 28 take away 3 gives you 25. And if you want to prove it, just take 28 off that side, take 28 off that side. That leaves you with y equals 25. Take away 28 is minus 3. Y equals minus 3. So I've worked out my value of x. That was through the elimination method. Then I substituted my value of x back in to one of the two equations to get the value of y. Now what I could do to double check before moving on from this question is plug in 7 and minus 3 back into this one just to prove that it works. So if I just want to do a quick check here, so x is 7, take away sign, so 7, take away, now 3 lots of minus 3 is minus 9. 2 minuses make a plus. 7 plus 9 is 16. And it says there, it comes to 16. So a quick check there has just proved that my two values of 7 and minus 3 do actually work for the 3 marks there, x and y. And I did the elimination method here for question number 18. There are other methods to solve simultaneous equations, but I chose the elimination method. Right, moving on to question number 19. Right, question 19 is worth 3 marks. The diagram shows a straight line L1, which is here, drawn on a grid. A straight line L2 is parallel, so if I think of it being parallel, it's going to be like there or a bit lower down, but they're never going to meet, so they'll be the same distance apart, like train tracks. It's parallel to the line L1 and passes through the point 0, minus 5. Find an equation of the straight line L2. Now, in order to find the equation of the straight line that we can't see, I'm going to find the equation of the line that I can see first. And the equation of the line is y equals mx plus c, where m is the gradient and c is the intercept here that it crosses through on the y-axis. To get the gradient, I need to find the change in y over the change in x. And what I mean by that, so if I find a nice obvious point, which is there, it goes through perfect. What it means by the change in y, so how far that is there, so that's gone from 4 to 5, so that's 1. So 1 divided by the change in x, so what's happened from 2 to 4 is 2 points. So there you go, the gradient is a half. The change in y divided by the change in x. And I always choose a nice obvious point where you can make a nice triangle and it meets exactly at perfect points. So the change in y, which is how far it's gone from there to there, so 4 up to 5 is 1, and from there to there along the x-axis is 2 to 4, which is 2, so the gradient is a half. Now for this equation then, so it's going to be y equals a half x plus c, and c is where it crosses through here, which is 3. So plus 3. That's the equation of L1. Now, if L2 is parallel to this, parallel means it's going to have the same gradient, but it won't have the same intercept. But that's what this tells us here. It actually goes through 0, minus 5, which is down here somewhere, but it's telling me it goes through the x number at 0, so that's here, and the y number at minus 5. So the equation of Al2 that we can't see is y equals a half x, the same gradient, minus 5. And that's what I'm going to put on my dotted line here. Y equals a half x minus 5. Now you could put this part here as y equals x over 2 if you like. So x over 2 minus 5, that's the same as a half x. But I've just tried to show you obviously here what the gradient is, which is a half. The change in y over the change in x. So it's important to remember this y equals mx plus c, which is the equation of a straight line here. That's the gradient, and that's the intercept on the y-axis. The line that's been shown for us here, I can create the gradient and find that out, which is a half. The intercept is here, which is 3. If it's parallel, you have the same gradient, but you'll just have a different point it crosses through on the y-axis, which is given there, which is the minus 5. So y equals mx, the gradient m, take away 5, which is the y-intercept. Y equals a half x minus 5 for the 3 marks for question 19. Moving on to question number 20. Question number 20 is worth 3 marks. Steve has a photo, which is this part here, and a rectangular piece of card, the piece at the back there. The photo is 16 centimetres by 10 centimetres. The card is 30 centimetres by 15 centimetres. Steve cuts the card along the dotted line shown in the diagram below. Steve throws away the piece of card that is 15 centimetres by x centimetres. So he's going to throw away that piece there that he's cutting along here. The piece of card he has left is mathematically similar to the photo. Work out the value of x for 3 marks. Now, when something is mathematically similar, it basically means it's an enlargement. So this part here, this card that's going to be left over, is going to be an enlargement of the photograph. So 10 gets up to 15 by a scale factor. 16 will get up to whatever this part is by that same scale factor. So I can find the scale factor by comparing this left-hand side and the left-hand side. What do you times 10 by to get up to 15? The way to work out the scale factor is do 15 then divide by 10. So I need to get my scale factor first. So my scale factor is going to be 15 divided by 10, which is 1.5. So my scale factor is 1.5. 10 times 1.5 is 15. This side ends up being multiplied by the 1.5 because it's mathematically similar. It's an enlargement. 10 times 1.5 gives you the 15. So 16 times 1.5 is going to give me this part here. So I need to do that next. So 16 times 1.5, my scale factor that I've just worked out, is without a calculator, but when you multiply by 1.5, you just times it by 1 and then add on half of what it is on top. So 16 times 1 is 16, half of 16 is 8, so 16 plus 8 is 24. So the length here is 24 centimetres from there to there. The question is actually though, work out what the value of x is. The whole line is 30 centimetres, I've just worked that out as 24, so x has got to be 6 centimetres for the 3 marks there. So we've got this photograph that's mathematically similar to the card that's left over. We find our scale factor, so 10 times something to get to the 15, so 10 times 1.5. I found that out by doing 15 divided by 10, which is 1.5. So my scale factor is 15. Then to work out what the top part of this card is, I do 16 times that scale factor. So 16 times by 1.5, which comes out as 24, times by 1 and add on half, 24. So 24 goes up to here. 30 was the whole line, so 24, we've worked out it must be 6 for the x centimetre line there, 6 centimetres for x, for those 3 marks for question 20. Moving on to question number 21. 21 is worth 3 marks. And we've got this diagram here, diagram not accurately drawn as standard. B, C, D are points on the circumference of a circle. So B, C and D here are points on this circumference of a circle, centre 0. ABE, this line here, and ADF are tangents to the circle. Angle DAB is 40 degrees, and angle CBE is 75 degrees. Work out the size of angle ODC. So O to D to C is this one here. That's the angle I'm trying to work out. So I'm just going to put an X on the diagram there. Now, there are several circle theorems, and there are several ways to answer a question like this. And the one difference that I've spotted that is normally the case in circle theorem questions like this, it doesn't actually state, and it doesn't ask us to write down the steps that we've used to get there. It isn't a starred question. It is purely, what's the numerical value? What's that angle here? So there are several ways to do it, and I'm just going to go through one particular route here. Now, all over the picture, there are angles available to be worked out, and I'd advise, as soon as you work something out, put it on there. The first thing I've spotted here now is that a radius meets a tangent at 90 degrees, and that's the same down there. As soon as I put that 90 degree symbol on, I've spotted here, angles on a straight line add up to 180, so 90 plus 75, take it away from that 180, leaves you with 15 degrees in that gap. That's just by angles on a straight line here, 15 degrees. I've got here a quadrilateral, a four-sided shape, and a four-sided shape adds up to 360 degrees. So in this part here, I can do 360, take away my 40, take away my 90, and take away another 90. So 360, take away 40, take away two lots of 90, leaves you with 140 degrees left over there. So I've worked out that this centre angle is 140 degrees. If that's 140 degrees there, the other side of it has got to finish off the rest of the circle. So this part here has got to make 140 get up to 360, so that's 220 degrees. And here I've actually got a quadrilateral as well, this side. So four angles here must add up to 360. I've got 220. I've got 15. If I can work out that one, whatever's left over gets me up to 360 for X. Now this is another circle theorem. This shape here, when it starts from the centre, the angle at the centre is double the angle at the circumference. So this angle here has got to be 70 degrees, which is half of the 140. So I've worked out three of the four angles in this quadrilateral here. So to finally work out X, I'm going to do X equals 360, take away the 70, take away the 220, and then take away the 15. So 360 and take away those numbers there. So add up these three first, then take it away from 360. That leaves you with 55 degrees for X that I'm going to put on my dotted line down the bottom that's already got the degree symbol on. The reason I think this question has not asked you to give your reasons is because there's so many different ways that you could have got to this 55 degrees here. I started off by spotting the radius and the tangents meet at 90 degrees. From there I got a quadrilateral with three angles already, so I worked out the fourth one by doing 360, take away these three, which left me to 140. From there I finished off the full circle, 220. Then I spotted the theorem where angles at the centre are double the angles at the circumference, so half of 140 goes there. And then I've got three angles in a quadrilateral. This quadrilateral here this time, 360, take away 220, take away 15, and take away the 70, leaves me with the value of X of 55 degrees for the 3 marks for question number 21. Moving on to question number 22. Question 22 is split up into 2 parts, A and B, 2 marks for part A, 3 for part B, 5 in total, and you can find support for part A with the top 40 clip number 36. Simplify, 3x squared y to the power of 4, all in brackets, cubed. Now that cubed has got to be applied to everything in the bracket. So first of all, the normal number, the big number at the front here, the 3 cubed. 3 cubed is 3 times 3 times 3. 3 times 3 is 9 times another 3 is 27. Then I've got an x that does have a squared on inside the brackets with a cubed outside. So the quick way of dealing with these, and again top 40 clip 36, is just times the powers. 2 times 3 is 6. Then the y, same thing, 4 times 3 is 12. So we cube the big number at the front, 3. 3 times 3 times 3 is 27. X squared cubed times the powers, 2 times 3 is x to the power of 6, and the same with the y, 4 times 3 to the power of 12. Top 40 clip 36 for support on those type questions. Part B, simplify, and then we've got x squared minus 9 on the top, and 2x squared plus 5x minus 3 on the bottom for 3 marks. In order to simplify this, because I've got these two quadratics here, I've got to factorise the top and the bottom to simplify it down. So the top is a difference of 2 squares. That's going to factorise to an x plus 3 and an x minus 3. So the top factorises down quite nicely. The bottom is a little bit trickier. Again, it's going to factorise down to the 2 sets of brackets. One's going to have a 2x and the other one's going to have an x. We are also going to have one with a plus and one with a minus, because we are trying to get to a minus 3. And the good thing is there is only one way of getting to a 3, and that's with a 1 and a 3. So I'm going to have 1 and a 3 in here. Which way around we're going to work out now, and one's going to be a plus and one's going to be a minus. So if I've got 2x, and I've got the 2x squared by expanding this one, 2x times the 3 will give me the 6x. So if that's a plus 3 there, and this one becomes the minus 1x, that will take it to plus 5x. So really, I've just worked out which way around these go by a little bit of trialing out and imagining what it would be when I expand them out. So 2x times the number that's going to be here, if it was the 3 and a plus 3, that would make 6x. And then this one, if it was the minus 1, when you expand this part of it, would take you back down to 5x. And that's exactly what you want. And what you'll find when you get to this point, you'll have the same on the top and bottom for one of the parts, that one and that one, that can cancel off. So your final answer is x minus 3 on the top, 2x minus 1 on the bottom. And that's this simplified down. Factorise the top, factorise the bottom, one of them will be the same, and they clear off there to leave you with this one on top of this one for 3 marks. And again, part A, top 40, clip 36. Let's move on to question number 23. 23 is split up into 2 parts, A and B, 5 marks in total, 2 for part A and 3 for part B. Yvonne has 10 tulips in a bag. 7 of the tulip bulbs will grow into red tulips. 3 of the tulip bulbs will grow into yellow tulips. Yvonne takes at random 2 tulips from the bag. She plants the bulbs. Part A, complete the tree diagram. Now, the fact that she takes 2 tulip bulbs from the bag means that when she's taken that first one, she doesn't replace it to then take the second tulip bulb from the bag. So that means these numbers on this part of the tree diagram are going to be slightly different. Let's start over here first. If it's 7 over 10 for red, that means it's going to be 3 over 10 for yellow. So that's quite straightforward. Now, to get to this part here, this little section of the tree diagram, it means that you've taken red out first. So if you've taken a red out, you're not putting it back. That means there must be 6 red left. Because you've got 1 in your hand already, that red one, there's 9 left over. Now, to get to this yellow line here, you've still taken a red to get to here. So it's still out of 9. But all of the yellows are left because we haven't touched a yellow yet. We only touched a red to get there. So this has got to be 3 over 9. Now, this part of the tree diagram means we've taken a yellow one. So a yellow has gone. That means all the red are left. So that means 7 over 9. But to get to the bottom line here, to get to another yellow, means you've taken a yellow already. So you've got 2 out of 9 there. So that's a tree diagram completed for the 2 marks. These are all over 9 because it's the second bulb we're taking out. We've taken the first bulb out. There are 9 left in for when we take that second bulb. This section here is after we've taken a red. This section here is after we've taken a yellow. Part B, work out the probability that at least, that's important, at least one of the bulbs will grow into a yellow tulip. So let's have a look at the route that will get us a yellow tulip. Now across the top there, we'll get you 2 red ones. So I'm not interested in that route there. But if we look at the next route, the first bulb is red, but then we get a yellow. So I am interested in this route. This one here would give me a yellow and then a red. So at least one yellow. I'm interested in this one. And at least one yellow, if I go down the bottom, would give me 2 yellows. So that is at least one yellow. So I'm interested in that route as well. So it's only the top route I'm not interested in, the 2 red bulbs coming out. Along the branches, we times our fractions. So times the top, times the bottom. So 7 times 3 is 21. 10 times 9 is 90. Again, the same with this one. 3 times 7 is 21 over 90. And the bottom line is going to be 3 times 2, which is 6, again over 90. At least one of these 3 options, I need to add these 3 fractions together. I'm just showing my working out by showing that I need to add these. When you add fractions, the denominator stays the same, which it is all the way through there, and we need to add the top row. So 42, so 48 over 90 for the 3 marks. I'm going to put it down here as well. 48 over 90 for my 3 marks for part B to work out that at least one of the bulbs will grow into a yellow. Red, red won't. Red, yellow, that's 1, so that's at least 1. Yellow, red, that's at least 1, so we multiply that one. And then yellow, yellow is both yellow, so that's at least 1 yellow, so we multiply those as well. Times along, and then add those 3 options up to get 48 over 90. And we can simplify that down as well, but I'm going to leave it as 48 over 90 for this answer to show you how we got there. Part B, 3 marks total for question 23, 5 marks. Moving on to question number 24. Question 24 is worth 3 marks, and we've got another starred element here, so we do have to finish off with a little sentence. We've got this triangle drawn, again not accurately drawn. We've got this vector m, which is from O to m here, and we've got a vector n on the picture, which goes from O to n. OAB is a triangle. M is the midpoint of OA, so that's right in the middle of that line. And n is the midpoint of OB, so that's right in the middle of that line. O to m, to get from there to there, is the vector m. And from O to n, like I said a second ago, is the vector n. Show that AB is parallel to MN. So I've got to prove that this line here, AB, and I'm going to join up MN now. I've got to try and prove that these 2 are parallel. So let's first of all work out what m to n actually is. M to n. So m to n with the arrow above it is from there to there. So I've got to go this way. So I've got to go against the m arrow. So I've got to go minus m and then with the n arrow. So plus n. So that is my m to n line, this one. Now because it says here that m is the midpoint of this line, I'm going to add to this picture that that is also going to be the vector m, and that there is also going to be the vector n. So to get from A to B, I've got to go down here and across here. So let's put this, A to B is minus m minus m, so that's going to be minus 2 m's, and then it's going to be with the arrow for the n, so it's going to be plus 2 n's. So m to n was quite straightforward, against the arrow, with the arrow, so minus m plus n. And A to B is going to be minus 2m, so against the 2m arrows, and with the 2n arrows, so plus 2n. Now this one, I'm going to tidy up a little bit. This A to B actually can be factorised down to 2 lots of minus m plus n. Now what you notice there, look, is m to n is there. That's the same answer there and there. It's just 2 lots of it. So I'm going to sum that up by saying A to B actually is equal to 2 lots of m to n. A to B equals 2 lots of m to n. From there to there is double the amount from there to there. It's 2 lots. Now, since AB is a multiple of MN, AB is parallel to MN. So AB is a multiple of MN. So AB is parallel to MN. And that sums it up to get our starred element, the quality of written communication mark that's available as part of the 3 marks for question number 24. We worked out what the vector is to work out from M to N, which is from M to N here. A to B is that one. It's a multiple, and since it's a multiple, they are parallel lines. AB and MN are parallel for the 3 marks. Moving on to question number 25. Question number 25 is split up into 2 parts, 2 marks each, 4 marks in total. Part A, rationalise the denominator of 12 over root 3. To rationalise the denominator, when we've got this surd on the bottom, we've got this root 3, we multiply both top and bottom by the same, by root 3. So this comes out as being 12 root 3 on the top, and root 3 times root 3 simplifies down quite nicely to 3. Then we can simplify this down even further. 12 divided by 3 is 4. So you've got 4 root 3s. 4 root 3s for part A for the 2 marks. Rationalise the denominator, multiply both top and bottom by the same as the denominator there, root 3. Times through, becomes 3 on the bottom, nice and straightforward, and then 12 root 3 divided by 3 is 4 root 3. Part B, work out the value of, and then we've got root 2 plus root 8 all squared. The first thing I'm going to do here is actually rewrite this out as in terms of double brackets. So it's root 2 plus root 8, all times by root 2 plus root 8. And then I can apply the parrot method of multiplication with the double brackets. This times this times this, the bottom times both as well. If I've got the arcs in the right place, put the eyes on, I've got my parrot's beak. Small arc first on the top, big arc second, small arc, and then big arc on the bottom. So root 2 times root 2 first is 2. Root 2 times root 8, I'm going to write it as root 2 root 8. Plus, and then the bottom, I've got another one of those, which is root 2 root 8, or root 8 root 2, doesn't matter which way round you write that. And then finally, the last arc on the bottom is root 8 times root 8, which is 8. This part here is going to get tidied up. So I've still got the 2 plus. Now, because they're next to each other, it actually becomes root 16. That's the same for that one, plus 8. 2 times 8 is 16. But the root of 16 is 4. So I've got 2 plus 4 plus 4 plus 8. Tidy that up, comes down to 18. Work out the value of, with a squared on, put it down as double brackets. Follow the arcs. A root 2 times a root 2 is a 2. The 2 square root symbols cancel off, it becomes 2. Root 2 times root 8, root 8 times root 2, same thing. Then root 8 times root 8, again, the square roots cancel off to be 8. These two can be rewritten as 2 lots of 8, which is 16. Root 16 is 4. Add up these 4 numbers comes to 18 for the 2 marks for question 25 part B. And finally, we're moving on to question 26. Now, question number 26 is worth 5 marks, and it has been split up into A, B, and C. The diagram shows part of a sketch of the curve y equals sine x, and we've got part of that graph there. Part A, write down the coordinates of the point P. Part B, write down the coordinates of the point Q. Now, we need to have our knowledge of what the sine curve looks like. The sine curve reaches up to 1 and dips down to -1. And the wave is completed at 360 degrees. So that means here is 180 degrees. this would be at 90 degrees, and this point here at the dip would be at 270 degrees. So our knowledge of what the sine curve looks like reaches up to 1, dips down to -1 on the y-axis. It's completed after 360 degrees, and then you can work out the sections at 90 at the top of the peak, comes down through 180, bottom of the peak there, 270. So the coordinates of P here is along the corridor 180, up and down the stairs it isn't, 0. So it's 180, 0 for the coordinate of P here, and the coordinate of Q here along the corridor is 270. Up and down the stairs for the next part, the y value is down the stairs at -1. So 270 -1 for the coordinate of Q. Here is a sketch of the curve y equals a cos bx plus c between 0 and 360. And for part C, find the values of a, b and c, these three values up here. Now, what I'm going to add onto this picture first is my knowledge of what the cos curve looks like. Now, the cos curve starts at 1, it goes down through 90, it peaks at -1 on the bottom there when it reaches 180, comes back up through 270 and reaches up at 1 again at 360. Now, I know it looks a bit odd there because it's the scale on the axis to get this new version in, but that's what cos would look like between 0 and 360 before these numbers have been applied. Now I'm going to leave this plus c till the end because that's the shift up and down that I can deal with once I've worked out what these stretching and compressions have done to the graph first. Now, as you can see, the normal cos curve has one dip down in normal 360. It goes down and up. This version of it has gone down, down, and down, 3 versions. So it's been squidged in and concertinaed in 3 times within 360. And that's what the value of B is, this here. This value of B is our horizontal compression. We've got 3 where we'd normally have 1. So B is 3. The next value I'm going to work out is A. Now, A is our vertical stretch. Now, I'm going to work out A and C at the same time here. So C, when we add on a value here, will shift the whole graph. But first, this value A has done something to the vertical shape of this curve here. So if it's gone from 1 and then it's been doubled this direction, it would have gone to 2. And then if we add 1 on, it goes up to 3. So that's the way this graph has actually got to start from 3. It's been vertically stretched times by 2 to get from 1 to 2. It's been doubled. So that means A is 2, because it's been doubled. And then from there, the whole graph has been shifted up 1 to start at 3. So C is a +1 at the end. So we've got A, which is our vertical stretch. We've got B, which is our horizontal compression. And then we've got C, which just shunts the whole graph up that value 1. So our value of A is 2, B is 3, and C is 1 for the 3 marks. And for both A, B, and C now, we do have to have a good knowledge of what the sine curve looks like and what the cos curve looks like. Great. Well, I hope you've done well on that question and the whole of this exam paper. Well done and good luck.